So we have a red ball that has a mass of 1.57 kilograms that is traveling this way at 2.35 meters per second. It is going toward a blue ball that has a mass. Hey, that was me.
How do you do it?
Magic. Okay, it's going toward a blue ball that had a mass of 1.22 kilograms, and after getting hit, the blue ball goes flying off this direction. So that's 31 degrees to the left of the original motion, and it is now going 1.73 meters per second. We want to know what's the speed and angle of the red ball afterwards. Okay? So, looking at this, we say we can divide this thing into two chunks. Over here is the before the collision, and then that's the after the collision. So, before the collision, Gabby, shh. Before the collision, all the momentum is in the red ball. So afterwards, it's going to be in both balls. So if the blue ball goes flying off here to the left, then the red ball is going to have to go to the right. It would only be a 90-degree angle if the masses are equal, but the masses here are not equal, so it will not be a 90-degree angle. Now, here it's really, really simple. We have to do a little bit of math. All we have to do is find some momentum. So we know that P equals mv. So initially, all the momentum's in the red ball, so all we have to do is find the red ball, 1.57 times 2.35 gives us 3.69 Newton seconds. So that's how much momentum we have before the collision. How much momentum are we going to have after the collision?
The same but divided into two balls.
We're going to have 3.69 Newton seconds after the collision also, because the total before has to equal the total after. But like Frank said, afterwards it's broken into two different balls. So the blue ball is going to go both forward and to the left, and the red ball is going to go forward and to the right. And so we know that the total forward is 3.69, so the red and the blue going forward have to add up to 3.69. Originally we had nothing going off to the side, so the total going left will have to equal the total going right. That's the physics behind it. Then it's just a little bit of math, and I mean a little bit of math. It's not bad. So here I got to find out what is the P that goes on the blue triangle here. So again, we have P equals mv. So I have m, I have v. If I multiply 1.22, 1.73. So I end up with 2.11 Newton seconds. And then I have this triangle. The 2.11 is the what of the triangle? The hypotenuse. So if I'm looking for this side, I'm going to have to use cosine. And if I'm looking for this side, I'm going to have to use sine. So if I take the sine of 31 times the 2.11, I find that this is 1.09. And if I do cosine, I find that this is 1.81. Now, we said that the total left has to equal the total right, so I'm just going to bring this puppy over here, and it's also going to have to be 1.09 Newton seconds. Because initially, before they collided, nothing was going to the side, so afterwards, nothing has to go to the side, so the total left and the total right have to cancel each other out. Now, we said we had 3.69 going straight forward, but now straight forward is in two colors, both blue and red. I know that the blue side says, hey, I got 1.81 going forward, I had 3.69 going forward, I seem to be missing some momentum going forward. How much am I missing? 3.69 minus the 1.81 gives me
1.88.
So I have this is missing, it must also be going forward, so this must be how much momentum is going forward in the red ball. So this is going to be 1.88 Newton seconds down here on the red part. So then you say, well, if I look at my red triangle, I have two sides, and I'm looking for the big side. I think I need to use Pythagorean theorem. So it's going to be the 1.88 plus 1.09 and we end up with 2.17 Newton seconds. Now, I'm not looking for what is the momentum of the red ball afterwards. I'm looking for what is the velocity. So again, if P equals mv, if I'm looking for the velocity, m needs to move away, which would be on the bottom on the other side. So we'll have 2.17 on top. The m I have to use here is the red ball, so it has to be the red mass, so it has to be the 1.57. So if we have 2.17 divided by 1.57, I'm going to end up with the red ball that's going 1.38 meters per second. So that's going to be one box on the test. The other box will be what angle is it flying at? And so that becomes super duper simple. We're just looking for this angle. And again, whenever we had this triangle, we said, hey, this side is opposite and this side is adjacent. So I'm thinking tangent to the minus 1, opposite over adjacent. Looks like that. And of course, if your calculator's in radians this whole time, none of this will look good to you. And so that came out to be 33.
Mr. Paulson, why is it the inverse of 10?
Find the angle.
Because I'm looking for the angle. Here I had the angle, so I just hit the buttons. But here I'm looking for the angle, so I have to hit second to get to that one. So our second box there is going to be.
I have a question.
Yes, sir.
Why does on the blue triangle the cosine say 181 and then on the red one it's 188?
Because again, the 181 and the 188 have to together add up to what the initial was here. These two are not equal but opposite. These two are equal but opposite. The sideways components are equal but opposite. The two forward together have to add what the one forward was initially.
Mr. Paulson,
Yes, sir.
the going up and the left and right are always going to add up to the.
They're always
They're
going to
all gonna
cancel
be
each other
equal.
out because we
Yeah.
didn't have anything to begin with, so they have to cancel.
Shouldn't we take a picture?
Is that for any case?
Yeah.